Good morning, evening, afternoon, wherever you are in the world. Hopefully, you're all having a pleasant weekend. Welcome to this evening's stream. Apologies for anyone regular out there for last weekend. Didn't have a chance to stream. I was kind of heads down, working on the next video. Just need a bit of time to get on with that. Luckily, I've kind of drawn a bit of a line under that on the technical side now. So now the sort of YouTube fun starts with the script writing and the filming and editing, etc., etc. But not what today's about. Today, I wanted to do a bit more C++. I think we've kind of been covering some interesting stuff on streams over the last weeks, months, however long we've been doing this. I like implementing the various standard library primitives. I think kind of give you a good understanding of how they, if you can get a good understanding of how they work under the hood, you tend to be in a better place to be able to use them effectively. I don't think it's, it's not necessarily a prerequisite to be able to use them, but I think it provides an interesting insight. We've done unique pointer, we did some template metaprogramming. I can't try to think what else we've done now, but anyway, I wanted to do std any because whilst it's not necessarily the most useful primitive, and I'll get into why in a minute, it's got some interesting implementation details, some interesting tricks that go on that are kind of useful to know. So we're going to start with that. I'm kind of thinking of maybe a larger project to do at some point, kind of like the hacking toolkit. I'm still kind of working on what that is. So yeah, we'll keep doing this until something else comes along. So I did not realise there was Formula 1 on, apologies. I'm not really that into it, so I try and keep a regular schedule, and if there's a clash, I do apologise. Anyway, so let's have a look at the mechanics of std any are interesting. So I'll kind of go through how it works and why you would use it and why you might not want to use it, and then we'll dive into the technical details. So let me just get up my tests here. So obviously we're going to be writing our own, but you can include std any. You can use std any from the any header, and std any came in C++ 17, and it's basically a way of storing any type you want in an object, kind of wrapping that object. It differs to something like optional, which because optional is typed, the class is templated on that type. So you have to declare the type that you want to store it up front, and then that becomes part of that type. So for instance, if you had I could have a std optional of an int, right? But here this type, this int here is part of the type. So if I had another one here, O1 and O2 are different types, so they can't be limited in kind of how you can interact with that and how they interact with each other. You can't copy one to the other, and more importantly, you can't store them in a container. So if I wanted a vector of std optionals, for instance, which fine, I have to say what that type is again as part of that collection. So I could put O1 into this vector, but I couldn't put O2, for instance. So the point of kind of std any is that the type itself isn't part, the type you're storing is not part of the surrounding any type. So any itself is not a templated class. You can put literally whatever you want in there. So I could have an A1 with an integer, and then I could have an A2 of a float. And then, for instance, I can then have a vector of any's, and then I could stick A1 and A2 in that, and that's perfectly fine. So this sounds great, kind of, it removes the need to tie the type of the object I'm wrapping to the type of effectively the wrapping object. I can stick them in a container. Like all things in life, there is no such thing as a free lunch. There is a trade-off for this kind of flexibility in the fact that the only way really to do it, at least generically for any type, is with a is with a dynamic allocation. So each of these will have to do a heap allocation in order to be able to store that object. There is a small buffer optimization that you can do, and we're going to look into that today, but by and large you kind of should assume that this incurs some overhead to be able to kind of get this kind of level of generic code. Thank you for pointing out my typo. And also then that kind of has a knock-on effect of the other usages of it. For example, now, if these are all heap allocated, then all we're effectively doing is storing in the vector as a vector of pointers. So you kind of lose maybe like the cache friendliness of the objects. You know, if I've got a bunch of optional, the size of the optional is the size of the type plus a boolean, potentially some bookkeeping stuff. So these can be these will be quite densely packed. You'll be very efficient on your cache, so iterating through them will be quite fast. Here, you're going to have to do a dereference through every object, etc., etc. So this is just boilerplate code, but I'm not too fussed about this. I'm going to delete all this in a second. This was just to kind of illustrate the mechanics of what we wanted to do today. So we basically want to write a class that can store any object, but is not templated on that object. And then that has some kind of interesting implications of, well, how do we make sure those object is correctly destroyed? How do we copy it? And etc., etc. And then after that, can look at maybe doing some of the sort of small buffer optimizations. So we're going to have to get the type back somehow. So the kind of the game here is like, how do you put in a type and remember it, but not have it as part of the type of the object in a sort of consistent and safe way? Because you still have to be able to get the objects back out. To get the object out of a std_any, you would use std_any cast. And here's the interesting thing here. So if I do it takes a pointer. So this will give me a pointer to the integer inside the any. But the key thing is that if this is wrong, so for instance, if I say, can you please get me a float to the thing that is stored the integer, this will return null pointer. So it has to somehow know whether any cast is valid or not. So again, we have to kind of retain some type information somewhere. So that's what we're going to be going to today. I think I wouldn't necessarily say any is is the most useful kind of vocabulary type or primitive in the standard. It has its place, but I think the implementation mechanics are actually quite interesting. I have used it once before. I had a base texture which had a bunch of virtual methods on it, and then say class OpenGL texture public texture, and then I don't know, say you have a metal one, a DirectX one, whatever, doesn't really matter. So by and large, through the design of those interface, I could just talk in terms of the base interface or the base class. That's kind of the whole point of abstraction and the whole point of object-orientated programming and all that kind of good stuff, is that you define the interface in the base class, and then anything consuming a texture doesn't care about the implementation. It doesn't care if it's an OpenGL texture or a metal texture, because you just give it a common interface that they all implement. However, at some point, the real world sets in, and this will have some sort of integer handle. It'll be like a GL uint, and this one will have some whatever weird handle, like a ID, because it'd be Objective-C++ or something like that. So I needed a way of getting that handle out in a consistent way. So I had virtual std_any handle const, and then each of these classes would implement that, and they would stuff their individual type into the handle, because the assumption being that at any point where I need to know that type, I probably know the type, so then I can just any cast it out, and even if I got it wrong, it would tell me. So anyway, that's one way I've used it before, is to provide an interface to getting out some very specific bit of data that I didn't want to pollute the top level interface with. Is that the best way of doing it? I don't know. It was the way I did it. Okay, so that's kind of where we're at with that. So yeah, someone's wondering how this works under the hood. So it doesn't use any other primitive, so it doesn't use a smart pointer. It does wrap a void pointer, so we'll kind of get into how that works under the hood. Yes, 50,000 subscribers, thank you very much. It's very exciting. I never thought I'd kind of get this far on YouTube, so enjoying that. Okay, let's go through this. I've waffled on enough. Let's write some code. Okay, so I've got my any class. So as we said, so we're going to have some public members and we're going to have some private members. So the class itself is not templated, so the class, the type that you're storing is in no way related to the any class, but we have to have a template somewhere because we have to be able to accept any type, and that would be in the constructor. So you have a templated constructor, which is going to take the object. So this is a forward reference because it's templated type, so we might be passing null value, it'll bind to the right thing, we don't have to worry too much about it. And effectively at the end of the day, we're going to need to be able to store this as a void pointer. We're going to effectively strip off that type information because void pointer is the kind of the lowest common denominator. Because it's a pointer, it will need to point to something. So the way we're going to do this is we're going to create a new dynamically allocated version of this object and copy it into it. That's going to be how we do it to start with. So effectively, obj then becomes new t, and then from that we can forward on our t obj. I think that's right. Pretty sure that's right. Might need to bring in utility. Okay. So why do I prefer to use class T instead of typename T? Yeah, it's less typing. There is, as far as I'm aware, there is no difference in this point in the grammar between class and typename. I just always type class. I get why people type name because T might not be a class. You know, if it's an int, then typename might make more sense. I've just always written class T. It's just what I've always done. Okay, so this basically allocates a new object and sticks it in that. So that's kind of the first part of it. Obviously, there's now a whole host of other issues that we kind of need to slowly start working our way through. Apparently, YouTube is not receiving enough video to maintain smooth something or other. It's cut off. So let me know if there's an issue on the stream. Not that there's much I can do about it, but YouTube has flashed up a warning at me. Okay, so what I'm going to do is first is like this. We're going to build this up bit by bit. So the first thing is to kind of get the value out. We can kind of test that. We won't be able to check whether that type is right or not, but we can start like working things out. So we're going to have a friend t star anycast any star. Right, okay, so make a friend method, which that is, so by declaring this method as function a friend, it can have access to the internals of this class. So this is how we can get the object pointer. So then we'll have a template cast t, this will take a t star, call it anycast, this will take an any star any, and then return static cast t star any obj. Okay, so this is kind of the first part. This this is kind of the first part of getting the object out. We're just going to cast it back to the type T. Obviously, there is nothing at this point to say whether that is right or not, so it would be undefined behavior if we get it wrong. We will eventually lead up to a point where we can safely return an null pointer when we know whether the type is right or not. But to kind of get us going, we can stick an object in. So I think, bring up my tests. So any we'll put an integer in, and then we should be able to do test. Sorry, I'll get that in a minute. Assert equal star my stood any cast int a equals 1. There we go. Got that in the end. Okay, so that passed. So ship it, ready to go. So we can kind of go through the motions of sticking an integer in and getting it out. However, it will fail if well, there's kind of two problems at the moment. One is it will fail, like it will not correctly detect if we try and anycast to the wrong type, so we'll end up with undefined behavior. And the other two is that we leak this void pointer, like we don't ever delete it. So I'm going to go through the deletion first because it's kind of a prerequisite to being able to finish fleshing out the anycast. So the question is like, well, so you can't just do delete obj, right? You cannot delete a void pointer, it's undefined behavior. If the compiler will even let you do it, because it's lost that type of information. It has no idea what destructor to call, and it now has no idea the size of the object to reclaim the memory. Even if there was some bookkeeping in the particular malloc implementation under the hood, ultimately you cannot delete a void pointer. So we have to be able to go back, get that type information somehow. So what we're going to do is we are going to create a function pointer to a function that will do the deletion for us. So the ever brilliant function pointer syntax. So I've declared a function pointer called detour, and it's going to take a void pointer. And this is a member, right? So I can assign this to something. So the question is then, what do I assign it to? If we have a templated method here called static void do detour, and this takes a void star of obj. Then what we can do is we can delete. We can safely static cast to a t star our object, right? Because again, we're going to call it with a known t ahead of time, and we're going to pass the object, and then from there we can just delete it. So what this then looks like is our detour. Keep it consistent, stick a underscore at the end of there. So detour, and then this will be the address of do detour t. This is all there really is to it. This is kind of the trick, is that we maintain a pointer, a function pointer to a static member, but we preserve this t here. So again, this is just a void. This is just a function pointer, but internally, because it's static, when the template is instantiated, it will kind of have that t information baked into it. So that's kind of how we can maintain that. So then we can just do, we can just call that with our obj. And that's kind of like the first part of it. So this concept here is called type erasure. That's if you ever see that or hear that. The idea is that we have erased the type to store in a void pointer, but we are using a pointer to a templated static function to effectively be able to bring that type of information back whilst not actually storing it anywhere. And then, so now the trick is, how do we tell whether in here, whether this was an integer or not? Oh, sorry, whether the type we supplied was correct. And basically the way you can do that is if any detour is equal to any do detour t, then in this case here, because this is static and you'll only get instantiated once, regardless of how many any's I create with an int, this will only get instantiated once and will only ever have one address effectively in memory. So if the detour of the object we've been given is the same as the detour of this type, then we know that those are, then this was the type we were given. So in fact, actually, what's actually even easier then is I can just do return, if that's the case, else it'll be a null pointer. And all my code's disappeared. Right. Fine, thanks. Thanks, client format. So that's really like the trick of it. There's a little bit more we're going to go into because there's some more interesting ways we can kind of flesh this out, and we still have to do copying and other stuff like that. But fundamentally, type erasure is the process of erasing the type. So in theory now, I should be able to do assert equal my stud anycast float of A1, and that should equal a null pointer, if I've done it all right. Nice, nailed it. Might have missed some details, and the reason why the do detour is static, just so there will only be one instance of it, or is the reason also related to how we'll know the type? Might have misheard something. No, this is kind of like the crux of it, so I'm happy to kind of go over this a couple of times. Static method here, again, so one, it's not, you don't have to call this on an instantiated version of the class, like there's no this pointer, it's just static. And just the way that template instantiation works is by the time it kind of gets to the linker and laid out in memory, it will have only instantiated, only one of these effectively gets actually instantiated and baked into the executable at the end. So every time, no matter how many any's I create with an integer, the actual reified code for this will only exist in one address. So it doesn't matter what any I pass in here, like if all any's that hold an int, this will always point to this particular instantiation of do detour, if that makes sense. And that's how we can check, because again, in this case here, when I place in float, so do detour int and do detour float are two separate functions. They have two separate addresses, and then the any detour here, if it's for float, won't equal the one for integer, if that makes sense. Hopefully that kind of makes sense going through it like that. And actually, I guess we can probably let's just convince ourselves that the destructor is working. So I'm going to do my classic struct check detour, bool flag check detour, bool flag, and then check detour flag equals true. So this this here is just a custom class or struct, whatever, doesn't really matter, where the destructor has an observable side effect. And then I'm going to do check detour with the addresses set, and then in my any I'll put in the D, and then let's scoop this like this so that when that goes out I can assert true set. So basically I've got a custom object that has an observable side effect. With the destruct has an observable side effect, I set up a situation where that destructor will be hit, and then I observe that. So hopefully, what have I done wrong? Type name declared a point. Cannot allocate reference type check detour with new. Pretty sure I can. Yeah, sorry. So someone's joining late. I'm just re-implementing random interesting parts of the standard library, just ones that I find interesting and have interesting mechanics. So we're doing std any today. I seem to have made a mistake somewhere. I'm just trying to. It's always fun trying to parse C++ errors live. Can I allocate reference type? This is because. This has deduced it as a reference, so let me just. It's not great, but just let's just take it by Yeah, okay, fine. I probably need to do what is it? Std remove. Is it remove ref? Remove CV ref. To actually get the. Just because the way the template type deduction works, it's trying to allocate a reference, which is not a thing. Std remove CV ref. If this doesn't work, then we'll just keep it. I'll keep it simple and just do it the slightly less efficient way, and then I can fix it up later. I'm more interested in the mechanics of it than yeah, whatever. We'll just take it by value. I'm more interested in the actual internal mechanics than fighting template instantiation errors. Because that is not fun for anyone. There you go, nailed it. Right. Okay, so it's no longer forwarding reference, it's just passed by value, but whatever. So it means there's an extra copy, but again, not too worried. Okay, so now the thing is actually we're going to want to copy the any and potentially move it, although I might not do move because it's pretty much mechanically the same as copying. So imagine I have imagine I have a copy constructor. Yes, I do find it funny how Twitch is censoring STD, well, whatever. I'm trying to work out what it is, what is being censored, but it's standard library, I guess. It doesn't like part of it, which is funny. So I can't actually answer the question when was the censored word introduced to the standard. Any came in C++ 17, along with optional, which is actually the far more useful. I would say the far more useful vocabulary type primitive. We'll do optional at some point as well. It's kind of interesting, but I think any is a little bit more in depth. Optional kind of just have to create an unaligned buffer and placement new and construct into it. Really, oh, actually, no, you tend to use the anonymous union trick to make it const expra, but whatever. We can go into stud option another time. Anyway, so I want to copy this. So the first thing we're going to want to do is we're going to have to. So again, we've lost the type information. So in order to copy something, which is effectively newly allocate someone and do this, we need to be able to remember that information. So we can kind of do the same thing as before. Is we can do copy. Let's have this return a void star, and then we can do return new t, and then we'll dereference that into that. So effectively, all we're going to do is in our type array, go through the type erasure again, but we'll have a static method which will retain the type information, and then through that we can just new it and then use the copy constructor of the underlying object to kind of do all the hard work for us. And then again, do copy t. So in any, nope, steady. I prefer to, that's the order I prefer. So obj will be other dot copy other dot obj, and then we'll need to do detour equals other dot detour, and then the same for copy. Assigning from void pointer. Let's have a look at the actual error. So the difference between optional and any is optional is the class itself retains the type information, so you have to template the optional on the type. So you do stud optional angle brackets int float my class. Because of that, the whole class is aware of the type, so it can then store it kind of on it's stack allocated. It will create a buffer big enough to store that object and then store it in it. Stud any, the class isn't templated, so the entire class does not know about that type. So the only way it can do it is during construction or copying or whatever, is to dynamically allocate the object and then use type erasure, which is the mechanics we're going through, to retain, kind of be able to pull that type information back at a later date. So the trade-offs are optional is stack allocated, so potentially more, doesn't require dynamic memory allocation. But each optional is a different type, so you can't say create a vector of different optionals can store in different types. And any then is kind of the opposite. It almost certainly involves a dynamic allocation, but you can store whatever for instance in a vector as of any different type that you want. Where have I gone wrong? Because this stores a void pointer. Nailed it. I suppose we better just do a copy test as well, just to prove I'm halfway knowing what I'm talking about. Although who really knows? I'm making a lot of this up as I go along. My stud any a1 in nope, it's not templated. That's literally what I was just saying. Auto a2 equals a1. And then assert equals a1 2, and then a2 is a2. And I guess we also want to assert not equal my stud any cast int of a1 is my stud any cast of int a2. Right, so what I'm doing here is just proving to myself that I've not just copied the pointer across, and I've actually allocated different objects, because they will return different pointers. Because, you know, it'd be easy just to say just copy the pointer across, but we've not actually copied the object. There we go, nailed it. Yeah, any is just a bit. I know what you mean. Any is just a bit too much. Any, it is a lot of the C++ primitive. Oh, sorry, there are a bunch of C++ primitives that are kind of effectively wrappers around like the old school C ways of doing it. So variant is a type safe way of wrapping a union, and any is a type safe way of wrapping a void star. That's really what it's used for. Anywhere where you would use a void star before, you should probably use an any. I guess that's a better way of thinking about it. By and large, the point of C++ is to not use void pointer, because you have templates, because you can retain the type information. You know, you don't. Your vector is templated on that type, so it stores exactly those objects at exactly those size right next to each other in memory. You don't have to store a void pointer to some unknown object. So again, that's why I don't think any is particularly useful. I just think it's more fun to implement, if that makes sense. So we could check as well that, you know, these are equal, but I think it's fair enough to just do one. So the problem we've got now is a sort of, every time we add another one of these members, these function pointers, the object grows a little bit, assuming you're compiling for 64 bits. Then each of these pointers is 8 bytes. So you've got 8, 16, 24. If we needed to add one for moving, then that would be another one. So really, we're kind of adding more, you know, every time we need to add a new type erased operator, or I guess an operator that needs to be able to retain the type information, the object gets a little bit bigger. So what I'm going to do is I'm going to refactor this. We're going to refactor this slightly to make it a little bit better. Yeah, I don't know. I mean, I'm sure the boost one. No, I know that the boost one is a lot better than mine. Remember, this is also in the standard library, so you can go and look at the libc++ or the stdlibc++ or the MSVC one. I find library code incredibly hard to read, just because they have to be so. I can take a lot of liberties with this. Like, I don't have to worry about anything I don't want to worry about. Whereas if you're building something that is to be used by anyone, then you have to kind of take it into a lot more detail. But maybe there's an interesting point. Maybe we'll have a little dig into one of the actual implementations. It will be better. I know you mean what you mean by when you say better is subjective. Better in my mind will be more rigorous and fleshed out. Whereas, like, for instance, I'm kind of taking a few liberties here and there just to kind of, because I'm more interested in going through the mechanics rather than building something people are actually going to use in production. So now that I've finished the newest video, am I planning on doing some more chill and less difficult videos for the next few, or are you planning on doing some quite large ones again? Oh, that's such a great question. This next video I'm working on is probably going to be technically it's the most complex one I've ever done. It's taken me weeks and weeks of, like, every spare minute I've had, I've poured into it, and I've finally gotten the technical content, not even like done. I've just had to draw a line under it because I've got about 90% of the way through, and I've literally I cannot spend any more time on it because I need to start doing the video. We'll see. Videos coming, like, ideas come and go to me as they do. It'd be nice if everyone was a massive video which got in hundreds of thousands of views and brought in more people, but those take a huge amount of time. So maybe we'll do, we'll play it by ear, really. We'll just play it by ear. But I'm really enjoying streaming, and definitely want to do some more streaming. Yeah, I agree. The mechanics are interesting, but probably wouldn't use std any, but it's kind of useful. Std function works exactly the same under the hood. It's a type erased function pointer. So rather than this being a void pointer to an object, it's a function. It's a void function, if that makes sense. It's a void function pointer. That's how std function works under the hood. So the function is actually is weirdly nuanced in the standard, because you can only put in copyable objects, because that was kind of like the base, I'm trying to think of the right word. That was the restriction that they basically put on it when they standardized it, is that you can only have copyable types. So if anyone's ever tried to put in a lambda, which owns a like a unique pointer into a stud function and not being able to do it. That's why. That's why in C++26 we're getting stud move function or something like that, or stud movable function to compensate that. But again, stud function works very much similar under the hood. Again, stud function almost certainly involves a dynamic memory allocation. So there's pros and cons to all this. Oh yes, Factorio stream. I do want to do that at some point. I might try. I've got a bit of time coming up. I don't want to promise anything, but I do have a bit of time coming up this week, so I might try on an evening that. We'll see how it goes. Or maybe, was it next week? We'll see. It'll be random. It'll just pop up. So keep an eye out. Yeah, I want to start playing some games as well. Just to try and. I really want to get into the Twitch affiliate partner scheme, whatever scheme. But I need to stream more than I currently do. Yes, I don't know about Space Age yet. I'm kind of still. I've only recently, to be honest, picked up Factorio, like the first one, so I'm kind of just enjoying like being bad at that before I pick up another game to be bad at. Again, all my free time I put into making YouTube videos, so I kind of just sort of pick and choose what I've got. You know what else I can kind of do. But yeah, be looking forward to playing some more of that. Okay, right. So the problem here is that I've now got eight more bytes than I really want. So what I'm going to do is call this I'm going to create a enum class command, and then from here I'll have like detour and copy. So those are my two commands, and then I'm going to have another function pointer which takes a command and a void pointer, and then what I can do is I can now unify all these into one static function which does the various different implementations. So template class T static void star do command and then void star obj. So I'm not really worried about constant correctness or anything like that. And this again, your stud any will correctly handle all that sort of stuff. Switch command C++20, so we can do using enum command, and then I can just do detour break, and then what's the other one? What do I call it? Copy break. Okay, let's start fleshing this out. So helps if I actually know what any of the syntax is. Why run Windows and not Linux? Because all my stuff's on Windows. I kind of have the best of both worlds because I do everything in WSL, so I kind of have a Linux dev environment, but I cross-compile everything for Windows if I'm doing Windows dev, or just build for Linux if I need to. So yeah. So the logic for this now goes into here, and the logic for this now goes into here, and then we'll just return null pointer, and I'll put that in the base one here, hoping the formatter tidies all this up for me. Brilliant. Okay, so now we can get rid of all this crap, and then we're just left with a do command, drop the detour, drop the copy, and then we have command equals do command, and then we drop that off, and then so now to detour, I did it wrong. Void star command. Oh, I've gotten control and command the wrong way around. Do control. There we go. Which takes a command. So control. Right. So now to detour, we call control with command detour, and then pass in the object. So this just keeps everything a little bit tidier. Obj equals detour, copy. And then all I have to do is copy over the control object function, whatever. Control equals other dot control. So hopefully that kind of makes sense. All I've done is just kind of unify all the functionality into one function, all the functionality into one static function. So it doesn't mean now, it means that no matter how many other commands, for want of a better word, I add, they just keep going to this one function. So I don't keep bloat the object any more than it already is. And it doesn't work. Oh, of course, because now this won't make any sense. So do control. Control does not name static. Any 14. Stupid function pointer syntax. Absolutely hate it. It just looks so different to everything else. And now I've got conroll. What do I think about C++ to program microcontrollers? I've never really done microcontroller programming. Oh, of course it doesn't work. I'll have a look at that in a second. But I genuinely believe that's presumably if the choice is between C and C++, I would personally pick C++ just because there's a lot more functionality and flexibility in the language. That doesn't mean C isn't the right choice for everything. I just think that given the choice, I would always pick C++ just because just for the start, there's so much more stuff out the box for you. And I think the fact that you get RAI as like a core feature is indispensable for fighting bugs and kind of producing safer, more rigorous code. So most of the stuff I do look at is Windows applications, so it does make sense to have a Windows machine. Again, because I heavily use WSL, I kind of get the best of both worlds, because WSL can, with Wine and stuff, can run some GUI applications as well. I did look at a Linux game. I looked at, what was it? It was crazy popular for about 5 minutes. The roulette one. Not roulette, the Russian roulette game. The name completely escapes me. But I ran the Linux version of that because I kind of wanted to use GDB and mix things up a bit. Have I ever used HalfBuzz for text layout? No, I've done some font rendering before for a graphics engine that I wrote, but I used just the built-in native APIs. I might have used FreeType actually. So you started with C++ just a few weeks ago, and you're really enjoying learning the low-level mechanics of it. But there's a lot of features. It's like drinking from water hose. Boxshot roulette. Thank you. C++ is. I feel really. I feel for anyone learning C++ in 2024, because you look at the language and there's just so much, and because there's this aggressive desire to not break backwards compatibility. Each new version, rather than you can't change or remove anything that's already in there. So each new version just brings newer things in to fix any previous problems. So best practices are constantly changing. So I do feel that you can get a little bit of analysis paralysis with it. And someone's saying they've just started looking at Boost. Yeah, Boost is pretty good. It's got a load of stuff in there that's not in the standard library. You'll find that a lot of stuff that gets standardized starts off in Boost. Boost is an excellent testing ground for features. So any and optional all existed in Boost before they were standardized. I use Boost a little bit. I find that C++ 23 now has a lot of good features in it, so I don't have to reach for Boost as much, but there's still a lot of good stuff in there. There's still a lot of really good stuff in there. Like ASIO is incredible. I'm still waiting for networking to arrive in C++. Anyway, what have I done? I've broken something. It's because I'm trying to copy myself. That's not going to work for anyone. Now that I've used NVim for a while, have I officially converted? Yes, I would say I'm pretty much a convert to NeoVim, back to NeoVim now. I was explaining this, I was talking to someone about this the other day. It's not the fact that I wanted NeoVim over VS Code. Like the VS Code's Vim bindings for me were pretty good. What I really missed was tmux, just the ability to kind of move between like this, just like, and I can split and I can just, tear up and tear down windows and move them around and have that absolute flexibility. Just I could not quite get something as close as that in VS Code. So Vim and tmux is basically my preferred kind of way of working. Why is my copying not working? What have I done wrong? So it comes in, does the copy, returns the new pointer, stores it in obj, and then it helps if I use the right control function. There we go. Right, nailed it. Okay, so like we could keep adding more and more to this. Like this doesn't currently support move operations. It doesn't support copy assignment. But again, those are kind of just variations on a theme at this point. In terms of like interesting things to do with this, the last one I want to do today, whatever, on the stream is a small buffer optimization. So again, we have to do a dynamic memory allocation every time we construct an object, which we might not want to. We might want to for certain small objects which meet a certain criteria. We might want to look at opportunities to optimize that. So the standard says for std any that implementations may do a small buffer optimization, but they're not required to. So you get absolutely no guarantee. It's one of those things where you'd actually have to go and look at the specific implementation that you're using to know what you get. But regardless, we're going to add it today. So there's a bunch of ways of doing this. One is to create so std byte buffer of like, I don't know, 100, and that's pretty aggressive. I don't know, call it, 25, and then if the size in the constructor, you can basically say if the size of t is less than the size of buffer, then we can construct it into this buffer, and that's totally viable to do. You can use placement new, you can use construct at, blah 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 blah. The problem with this is that even if you don't use it, you are always having to cart these 25 bytes around. Your object is instantly the size of this buffer bigger. And the other one is because I don't have the type information here, there's potential issues around alignment. So I'm going to opt to not do that. What I'm going to do instead is basically abuse the fact that this pointer takes up some space. And so I'm going to say if the object is 8 bytes or less and is trivially copyable, which means that it's safe to memcopy it, I'm going to stuff it into these 8 bytes. So that's what I'm going to do for this. So we'll see how that goes. So I have only done SFML and OpenGL game development. I have a really bad habit of starting projects and then finishing them, so sadly not much to showcase. Spiraled into a specialist in a lot, but a master of none. Master at having an idea of how to start anything. So I think any developer in the world, anyone who's ever written any code, can empathize with you there. I am also exactly the same. It's doing something new and is fun because you've got all the ideas in the world and you can totally you can just see all the greatness that lies ahead of you, and then actually once you start working on it you realize it's work. Motivation will start a project, but motivation won't finish a project. It's kind of discipline that finishes a project. So you've got to pick something small and well scoped and something that's doable either by yourself, with the skills you have, or maybe just a bit beyond your skills if you're pushing yourself. And then you've got to have some discipline. Every day I'm going to work an hour on it, or every other day I'm going to work an hour on it, and you just keep chipping away at it until you reach some definition of done. But yeah, I think that's just life. I am tempted to try and make a game next year, but all on stream. So like, I mean, I'd probably have to do some stuff off stream, but by and large, if I want to work on the game, I have to stream it. I think that might be fun. I need to kind of check with the other commitments that I have in my life, that is kind of doable because I probably want to be streaming, a couple of times a week. But I think that might be fun, like literally going from scratch, like nothing to a game written in Scratch with OpenGL. I think that might be fun. So C++ is just so damn cool. A shame there's literally no dev jobs for it where I live, and if there's any, it's for STEM degrees. I can't really. I don't know where you live, and I absolutely don't encourage you to reveal where you live. There's presumed possibility of remote jobs, but yeah, I think C++ is a great language. It's not the best language because there's no such thing, but it's for what it does. It's pretty good. It definitely has its issues, but then again, so do all languages that people use. Yes, the worst part is when you have to accept that you think you're 90% done and there's still 90% to go. That has been the latest video for me. I got down to what I thought was like the last 10%. I was like, I just need to do this one bit, wrap it all up, tell a nice story, and then I can kind of get on with all the other bits and pieces I need, actually filming it and stuff. And I have spent weeks and weeks on what I thought was the last 10%. I've spent more time on the last 10% than I spent on the rest of it, and I had to draw a line under it today and be like, this is just enough to do a video because I cannot spend any more time on it. Yeah. Right, so let's have some fun stuffing data into a void pointer, not having the void pointer point to it. So the constructor is the obvious place to start. So we're gonna make this a null pointer to start with, and then again, because we have the type information here, so what we're going to do is I'm going to need to include. Obviously, memcopy is in C string because where else would it be? So, if const explorer size of t is less than or equal to the size of a void pointer, then std memcopy, again, not what object is pointing to, but the address of object itself, right? The actual address on the stack where that pointer lives, obj, and size of t. So this is kind of how we're going to get that small buffer optimization. I'm kind of treating this as a small buffer of 8 bytes that's kind of given to us for free, and I know this type, so at compile time I can basically just say, if this is the case, then do this. I think we're going to want as well and std is trivially copyable t, because this will, if an object is trivially copyable, then the standard says that you can copy it by memcopying. So it basically means it doesn't have a destructor or virtual methods, or it has a whole bunch of restrictions on it, which means it's safe to memcopy it. So that's, and then the else branch is what we had before, which would be obj equals new t obj. Again, we're using const expr if because this means at compile time, then only this code will be included, or this code will be included. So it's not a runtime. It's not a runtime check. It's a compile time check. So any and any that's not much better. And any object which satisfies this criteria will only have this code in the constructor. It's just a nice, do it if we can. Make const expr all the things. What if you put an any in an any? Then the any will just be a void pointer to an any. It should just work. There's no kind of, you could be any's all the way down. And so now we have a little bit more to do, because this will crash pretty hard if we try and do any of these other operations on it. So now we just need to, so if const expr size of t is greater than size of void star, then so we only want to do the deletion in the case where we've done a dynamic memory allocation, because deleting a stack object is undefined. Well, we don't have a pointer to it anyway, so that would crash. Someone in the chat who loves C++. I would avoid. I think it's great that you kind of found a language that you like, and you can kind of start to get build up expertise in. I would encourage you to not think it is the be all and end all of all languages, because there's no such thing for like any language. So by all means, like, really dive deep in C++ and learn its nuances and kind of strive to become an expert in it. But it will not be the right language for every single problem. But I guess try and find problems that it is a good solution for, if that makes sense. And then copying is similar. So if const expr size of t is less than or equal to the size of void star, then we can just std memcopy in the oh, actually no, because we're going to return a void pointer and then sign it in. So what we'll do is we'll create a void temp, and then we'll std memcopy into that temp the address of obj size of t, and then return temp. So this might look a bit strange, but basically we're kind of abusing the fact that we return void star, so 8 bytes, and assign it here. So by creating a temporary one, stuffing the object we've been given, which we know is not a pointer, is actually an object that's less than 8 bytes, into that, and then returning it kind of through those mechanics. It ends up working out. Again, this is you'll get a copy of the pointer object here, so it's okay just to take the address of it. When you now leak memory if t is less than 8 bytes. Oh yeah, I need to put the is trivially check in here. That's a good point. I've not done that. This I'll tidy up later. This all needs to be consistent. But yes, you're right. This should only be in the case. Unless I misunderstood what you mean, wouldn't you now leak memory if t is less than 8 bytes, but not in trivial? If it's less than 8 bytes, but it's not trivially copyable, then it will allocate this, and then I need to just accept this. If const expr size of that is less than or not std is trivially copyable vt. I think that's right. Is autocomplete. Hello. Trivially copyable t. Right. Hopefully that's enough. And then the final thing is I still need to return a pointer to the object, even though the object is stuffed into the space occupied by a void pointer. So I think here we now need to do, so basically if any control doesn't equal any do control t, then just straight return null pointer, there's nothing left to be done then. And then we can do if const, let's copy this because I can't. If const expr else return static cast t any obj. Right, so this is the non small buffered case. I'm gonna go get ready for a uni day tomorrow. Before I go, your opinion on Docker? Docker's brilliant. Use it all the time. I think it's great for building reproducible environments. I can't really have much more of an opinion than that. You should use it if it makes sense. If you don't know all possible types of compile time, I use any, but personally use variant in most cases. Yeah, or optional. I think optional is also good, because variant assumes it's going to be one or two types. Okay, so now just thinking about this, what do we want to do in this case? We need to return. I think we're going to have to reinterpret cast because it's absolutely not going to like what I'm about to do. The address of any object, because that's basically saying take the address of this object here and reinterpret cast that as a T star. What? Where has that come in? Right. Okay, so now we need to write a test for this because we are good engineers and we test our code. Small. Well, I guess actually I've been trying this with small objects anyway, and it continues to work. So I guess that's for free. What we could do is let's try something. Let's try something different. Let's. No, actually, that's not going to work for us. Okay, so I'm going to assume that's still working. So I guess. Just checking, see if I've missed anything, because it should now work for small objects. What we can do, I think, just to convince ourselves this is working, is let's comment out all that. And then let's do yes, write test fails, delete test. Cease to live. Okay, let's do cease to int. Okay, fine. Getting there now. So it's, oh, actually, I want stood def. Fine. Stood size t g allocations. And void star operator new stood size t size return stood malloc size, and then void operator delete void star obj free. So what I'm going to do is, what you should tend to avoid doing is I'm going to override the global new and delete so we can keep track of the number of allocations, that the amount of memory we're allocating. So I want to kind of do this just to prove to ourselves that we're not doing dynamic allocations for small objects. Thank you for the kind words. I'm glad you're enjoying it. So let's create a. Let's do. Get there in the end. My stood any, and let's put in a char. I don't know, 100. Something that's definitely bigger than a void star in there. A1. I keep ignoring everything I've said, which is like, oh, it doesn't have to be a. It's not a templated class. Can I do that? That's not syntax, is it? Right. Okay, fine. Char buffer 100. but that's going to indicate to a pointer. Fine, whatever. Struct large. Struct large. Right. That is itself trivially copyable, but it is a large object. So what we'll do is we'll do large. Right. Okay, so hopefully now we can see that assert equal G allocations is, I'm hoping it's that, but I guess we'll find out. What have I done wrong? I'm more just interested in the amount it's allocated, but because I'm only going to just write a few ad hoc tests to do this, I wouldn't actually include this formally as part of it. I guess I should remove this over to the test one. But yeah, I guess we could keep track of those there. But then I guess no, you're right, because we can't decrement it here because we have no idea of the size. It's literally the whole point. I think someone just pointed that out. Right, what am I doing? I guess that should be static for a start. Function previously declared with an explicit exception specification. What? Void operator. Does this need to be no except? Is he going to tell me why it didn't? The only problem with C test is it doesn't always tell you why something failed. 4, 5, 5, 6. Oh, is it doing? Oh, I bet it's all the G test crap it's doing as well. It's allocating. Fine. Well, I guess we can just remember the number. So 4, 5, 5, 7, 8. This isn't going to be quite the good test I hoped it would be. 4, 5, 5. Is that less than 100 difference? I've kind of lost the tracker. I've lost the point a little bit here. See if that works. I was just trying to prove that this doesn't allocate any extra memory. So now it's, yeah, so great, okay, fine. So there you go. So this is now 0. Right, fine. So that's 0. But if I change this to 9, for instance, so go over that threshold, then this should fail again because it allocated 9 bytes. Okay, it's kind of hard to, it's really tricky to kind of test stuff like that because you don't really want to be globally overriding new and delete because it has all sorts of implications. But I think just as a quick, as a super quick and dirty test, hopefully that's proved to you that this now has some sort of small buffer optimization. The idea being that if this criteria is met, then we do not do a dynamic reallocation. So then actually storing small objects in here and putting them in a vector is going to be pretty efficient. We've got some hairy kind of void pointer shenanigans, but again, it's all just type erasure under the hood. Let's have a think. MSVC. I don't really have much more coding to do today, but I'm going to hang around for a little bit, and there's a few little things we can go through. I'll just see if I can find something quick. All right, so this here is Microsoft's implementation of std.any in their standard library. Kind of curious as to, again, it's going to be pretty horrific. So they've already, I can see here, they've got, oh, are they interesting? They make it a context for a bool. I guess maybe because they wrote this before concepts, but they check the alignment and they check it's trivially copyable, and size of t is any trivial space size, which is the small object num pointers minus 1 times the size of void star. So they are, I've not looked at this before, they look like they're doing something similar to what I did, or at least on the face of it. But they have a small object number of pointers minus 1. So they have, presumably, rather than just stuffing it into a void pointer, they have what I guess like an array of void pointers effectively. You know, they have some number, it can take up some number of void pointer sizes of space. That's not an English sentence. I mean, where's this defined? I'd be interested to know what that is, but I guess I'll find it somewhere. The interesting about std.any as well is it works without RTTI. It doesn't retain runtime type information. It doesn't use type ID, or it doesn't retain any of that type information because it just goes through the type erasure machinery. Any big RTTI, hand roll vtable for types that must be heap allocated in an any. So again, look, they've got a destroy function and a copy function. These look very similar to what we had. So they delete the target and then they new allocate it. But I guess this type itself isn't templated, which is... Oh, sorry, yeah, these are templated. Interesting. Okay, so they have that. And then they've got any small RTTI, so a hand roll vtable for non-trivial types. That can be stored internally in an any, and then they have destroy, copy, and move, and then they destroy in place, construct in place, and construct in place. I'm going to guess this means that it uses std destroy from the standard, which basically calls destroy at, which does this absolute horror for you, which manually calls the destructor. Yes, because they're constructing it in place. So they've basically given a target, so a pointer to some space. They are constructing it in that space, which is equivalent of placement new. If anyone's ever seen that, it basically says, I want to new this object, but I don't want you to go to the heap. I want to give you the space to construct it in, and then you have to destroy it at that place as well, because when you use placement new, the destructor is not called for you. All right, those are questions. Love to see if you can help optimize one of my CUDA crypto algos. I've never used CUDA before. I've used I used OpenMP and OpenCL back at university, which was some number of years ago, so I would not be very, very good at it. Although, do feel free to submit it to the code review form. I've had a couple of good submissions on that, but unfortunately most of them have been in areas that I don't have a lot of knowledge in, so like non-C++ projects, so I've not really had a chance to be able to do any more videos on that. I really want to do more live code reviews. I'm just kind of waiting for some more projects that I can actually kind of fill a live stream out of, actually be able to talk for a couple of hours on, if that makes sense. I know you've had learning Go, Rust, X language on the never-ending list of interesting things to do. Have you ever thought of doing a learning X language stream where you just set a few milestones? That could be interesting, yeah. I mean, it might force me to actually sit down and learn Rust if I kind of have to do it live. Yeah, that might be quite interesting. I have like two go-to projects when learning a new language, which is a ray tracer and like a network server. So maybe doing one of those in Rust might be fun. And then maybe we could do the same thing in C++ and see how it compares. I do want to do a stream on coroutines in C++. I want to build out a little network server on that. That might be a couple of streams worth because coroutines are complex. And they've got just declaring an actual object, a const expert object of that type with those in blah blah blah. Okay, so class any. So that's the copy. So this is the copy constructor based on rep, which I don't know what we'll have to find what that is. Storage type data and rep mask. So I guess that is going to tell, that is how the object is going to store whether it's like a small buffer optimization or what they call like big RTTI and small RTTI. So yeah, here you go. Any representation small, then it's going to copy that data in. If it's big, then it's going to have to go do the big store in. And if it's trivial, then it just mem copies it in. So that's quite interesting. So they kind of at runtime check, unless this is const extra, which is not. So they runtime check what method they do, whereas kind of similar to mine, I guess. Whereas, well, I can compile time check because I'm only relying on information that's available that the compiler knows, whereas their implementation, I think they have to have more information, which is only available at runtime, so they have a switch. But it's very similar to what I was doing. Then the move operator, so there's move from. And then somewhere must be the actual, where they actually construct it from the object. So this is the in-place one. Where's this, the standard one? There you go, value type any. So they take a forwarding reference to the value, and then they so this is what I needed to do. They need to decay the value type, which basically strips off the CV reference operators, and then they can just use their in place method, which I'm going to assume constructs it in place. Let's see if we can find that. So takes decayed type and some number of arguments. If a compile time, it is trivially any trivial, which I think I saw at the top was trivially is a trivial type, then they get a reference to the trivial data, and then they just construct in place over that object, which is kind of what I was similar to what I was doing. They use references, doesn't really matter. They're going to just interesting. So what I think they're doing is they're actually still, whereas I just mem copy the object straight over, they are constructing it in that place. So basically, I guess the problem with the limitation with this is that if you had a small object that was copyable, I guess I wouldn't make it trivial, but if this object had a constructor or a copy constructor, then this wouldn't get called because you're literally just copying the byte representation of it from one place to the other. I think they, again, this is part of having a much more fuller implementation. This will trigger copy constructors and etc. As needed for even for small objects. Yeah, interesting. So this will construct in place into the trivial data. So this will still call the object's constructor even if it's trivial, whereas mine will not call a constructor because it literally just memory copies it in. And small storage. So interesting. These are their storage types. So you've got small storage, which is any small space size, and a pointer to their RTTI, which I think is their like control block. Then big storage is padded, again, bigger object, and then they've got storage, which is a union between them. So I guess it based on, so it kind of stores the right type. But yeah, I guess theirs is 450 lines. It's actually not that bad. 450 lines of standard style code, not bad. Wasn't actually planning on implementing anymore. Everything else is kind of just built off on that, like copy assignment is just making sure that you call the destructor on the one you've already got. We kind of covered that with unique pointer. Yeah, I think so. So, what was I going to say? I lost my train of thought there. My plan is to kind of work on the next. I'm working on the next video now, so the technical content is done, or at least as much as I can stomach to do. So I'm writing the script at the moment, hoping to film that and edit that this week. I'm hoping with a fair wind, I can get that up for next weekend. And then, as with the Diablo one, I'm tempted to, if it gets a good response, or if it doesn't, do a couple of live streams going through the technical content on that, because there is quite a lot to go through, and just by the necessity of how YouTube works, so we'll have to kind of strip a little bit of that out and kind of streamline it a bit, so we can kind of go through the technical side in a more sort of slower, casual pace, in a more less formal setting. So probably a couple of streams on that. Then I really want to do coroutines at some point, so I might build out a little C++ network server from scratch. That might be a stream or two. I really want to go over optional and shared pointer at some point. I really want to do vector, but vector is complex. Vector is really complex. I'm not that interested in doing like map and like red-black trees and all that rubbish. I think variant is complex as well. I think I'm not sure I've ever actually managed to successfully implement a variant. Like I'll have to go and have a look. I think it's quite complex. Tuple I've done. Tuple's interesting, so we could do tuple. I'll have to have another think about variant. Yeah. I think so you could do variant reasonably trivially using this type of erasure method. I think there's a better way of doing it with like templated unions, but I'd have to go and have a think about it. That'd be one I definitely have to go doing before the stream rather than trying to do it all live. But yeah, I think that's good. And then I kind of want to make a game at some point, so we might stream that at some point. But yeah, I got a few ideas. If people have ideas of what they want to see me do, then feel free to shout them out or sound off at some point. It's always good to get opinions in. I'm gonna wrap it up there because I have been absolutely hammering away this video for the last few weeks, and I'm exhausted. So it was fun hanging out with you guys, doing some C++. We'll definitely do some more C++ soon. Before everyone disappears, I have a gift for the YouTube people watching. I have 5 more gifts. Yes, there's a beer in the fridge with my name on it. Congratulations to 5 people who are chosen randomly. You get given a month's worth of free membership for the channel. This gives you access to a few behind the scenes bits and pieces, as well as early access to the videos, so you'll get to watch the new video before everyone else does. What I might try and do, actually, this is something I'm thinking of, is instead of, if I can get the video done this week rather than streaming next Sunday, is do a live premiere of the video, because it's probably going to be my sort of most complex and biggest video yet. On YouTube you can set up as a live premiere, so we all kind of watch it together, and there'll be like a live chat, so it'll be kind of like live streaming, but we'll watch the video. I'm kind of tempted to give that a go if it all works out. Obviously if you're a channel member, I will upload another copy for you to watch a few days early, but for everyone else, and obviously hopefully you could come along to the premiere anyway. But yeah, it might be, it's one of the few features of YouTube I'm yet to try out, so I think it might be fun to kind of, you kind of set a time and then no one can watch the video to that time, and then there's like as far as I'm aware, there's like a live chat window. I don't know if anyone experienced this before, but I'm keen to give it a go. But yeah, I'm just playing for time now, so I hope everyone has a pleasant weekend, and I will see you all soon. Thanks very much for coming along.